Hello all, good morning. Welcome to this Kubernetes session. So today we will be talking about the services. Okay. Till now we have just created a pod, and after that we have created pod with replica set as well. So replica set is mainly for the auto healing purpose. So till now, as we were discussed about the pods and replica set. So what we have done so far, we have created a Kubernetes cluster. Okay. So let's say this is our Kubernetes cluster, and within that cluster we have two worker nodes, one worker node and two worker node, and this cluster we have created with the help of DigitalOcean. Okay, it's very easy to do that with the DigitalOcean. That's why I prefer to do that. So this is our Kubernetes cluster. This is our worker one, and this is our worker two. And within that we have created pods. Okay, so let's say one pod over here, automatic one pod over here. So this is the setup we have done till now. In last 2-3 days we have seen these things. But how about accessing to these pods? Let's say if you want to access to this pod from outside, like outside with from the browser, then how we will be able to access these pods? So same fundamental है जैसे we have done in the Docker section. Like if you remember, like in the Docker section we have used -p command and done the port mapping. That time we have make use of this command, like while creating a container -p 8080 colon 80. This 8080 can be any port, any free port over the Docker host, and this 80 belongs to the container port. So what we have done, so in that case, whenever you used to hit the IP address of the local host, sorry, the Docker host, let's say colon 8080 over the browser, in that case a request will go to this particular container. Okay, so this is how we have done in case of the Docker. So similarly, in if you want to do it in the Kubernetes as well, we have to map the port of this any of the worker node, uh, okay, to this pod. So how we are going to do though all those things we will be able to handle with the help of services. Okay, so let's say this is we have just, let's forget about the worker node now, because anyhow the pods will go on worker node. So let's say this is my one of the within this I'm going to create a pod. Let's say this is, there are two pods that are belong to the front end pods. Okay, and if someone want to access to this front end pod, then definitely if you remember, in case of the Docker Compose we have created a service, okay, with the name front end. Name of the service can be anything, so let's say my front end service. And internally whenever I'm going to like connect to this service, then let's see, if I go to connect to this service, then internally this service is going to send request to any one of the pod. So this service will act as a load balancer, and this service will act as an interface between the user and this pod. Okay, so all the requests will get redirected from this service to this pod. So you can consider this is nothing but one of the load balancer at Kubernetes level, who is going to balance the number of requests between the number of pods. So if you get 10 requests, then uh, on round robin fashion, so first request will go to the first pod, then second over here, then third again, fourth again. So likewise, one by one a request will get redirected to each and every pod over here. Okay, so we are going to learn this service now, how to create service, and we will see the practical of that service as well, so that things will be much more clear. So to create service we will be working on the code that I think we already have the code along with us. I'll just copy this. I'll explain what exactly this code is all about. Okay, so kubectl get pod. Do we have any pod available with us? No. Okay, so let's create a pod. Kubectl, I think we have pod definition as well along with us. So what we are going to do, we are going to create a pod with, let's say, label type equal to front end, and the image will be nginx, rest of the things will remain the same. And I'll say front end pod. So main thing is like what image I'm preferring and what label I'm providing. Let's apply this. So pod will get created over here. Now to access to this pod from outside, we have to go ahead and create a service. So let's say service.yaml, not like this. Okay, I haven't applied it, I just copy pasted. I'll explain the content. So we have this pod available over here जिसका label है type equal to front end. Okay, and in this service.yaml, just main thing over here, just keep in mind selector में क्या आता है, हमेशा labels आता है. ठीक है, so in short, let's say we have these two pods having a label type equal to front end. Let me write it down. Okay, and let's say there is one more pod over here जिसका लेबल है type equal to backend. Okay, in that case this service will never send request to this pod. So based on what thing it is going to, so based on what thing this service will come to know कि कौन से pod को request redirect करना है and कौन से pod को request redirect नहीं करना है. So in the service file, if I write selector as type equal to front end, in that case this selector is going to send a or redirect or transfer the request to only those pods having type equal to front end. ठीक है, so label is much more important at this case, because if the labels are matching with selector, then only service is going to forward request to that pod, otherwise not. That's where I have written selector type equal to front end, because the pod which I have created uska label type equal to front end hai. Okay, and next is like kind equal to service. Okay, so as we are going to create service over here, that's where kind equal to service. Metadata may always a name of the service will come. Let's say my NodePort service. So actually there are three types of the service over here within Kubernetes as of now. Actually there are four, but we will discuss about three right now and one later on. One is like ClusterIP, one is like NodePort, next is like LoadBalancer, headless. Okay, so mainly there are four services available within this Kubernetes kind of world, and we will going to learn every service out of it, but let's focus one by one. So I'm just going to explain the NodePort service right now. Okay, so that's where type equal to NodePort, as which kind of service you have to go ahead and create, that is nothing but a NodePort. We'll explain the difference when to use which one. Okay, then as we have done the port mapping in case of the Docker container, same thing we are doing over here. Like target port is nothing but a container port. Okay, what is the container port? 80 because Nginx always works on the port 80. NodePort is nothing but a port on the node. Node is nothing but our worker node. Okay, worker node का कोई भी एक free port. Okay, in case of the Docker we have used 8080. Okay, but that is not possible to use over here because as per Kubernetes standard, the range of the node port that we can use is belongs to 30,000 to 32,767. So this is the range of the IP address, sorry, range of the port that we have to go ahead and make use of. So that's where I cannot use any port below 30,000 and greater than this number. So that's where we have used a port 30,008. Okay, you can use 30,009, 30,010, anything beyond this range, between the range. Okay, and this port is nothing but a service port. This can be equal to the target port as well. So this is not that much important. Important are two things, like the container port, that is the port 80, and the node port that we are specifying over here. Okay, so once you are able to create this service, then with the help of this port over the node, you will be able to access to our container. Now let's see in practical how things will work. I'm going to save this file. Let's apply this. So a service is going to get created. kubectl get svc is a shortcut for the service. You can write kubectl get service as well, and you can write kubectl get svc. So I'm going to prefer svc as a shortcut. So this is the default service which Kubernetes is going to provide. So this service I haven't created. Once you create your account or once you create your cluster within this DigitalOcean, you will see this default service. So let's ignore that. As of now, whatever the service that we have created, focus on that. Okay, so name of the service I kept as my NP service. The type of the service that I have created is this, and a random IP will get assigned to that service. And this is the node port. Okay, 30008, which I have kept as a node port. So if you want to access to this, I meant to say, now how come you will come, means how you will come to know that this service is going to redirect requests to the or transfer request to this pod. Okay, just by describing, if you do describe to this service, you will see endpoints. As this endpoints is nothing but if this service is going to transfer the request to these two pods, then we will get to see the IP address of these two pods in the endpoint section. Okay, so that is the nothing but this IP address. So this IP address belong to the front end pod. If I want to show you that as well practically, get pod wide. So this IP address ending with 193 belongs over here. So this IP address belongs to the pod colon 8080 is a container port. So that's where this service is going to send a request. If any request comes to this service, the request will get transferred to this pod. As there is only one pod right now, so all the requests will go to this pod only. But if I create one more pod with the label type equal to front end, then request will get divided like 50-50%. Okay, so that is the thing over here. Now if you want to access this pod, okay, this pod from the web browser, okay, so how you'll do that, we just have to get the IP address of the node and make use of the port 30008 over here. If you want to get the IP address, just provide -o wide. External IP, these are the two nodes that are present within our cluster. And external IP address is nothing but if you want to access it from the browser, then you have to go ahead and make use of the external. Any IP address will work over here. So let's go ahead and make use of this 30008. Now you can see this welcome to Nginx is appearing over here. Okay, let's see if I change the content within that pod. Execute -it user share nginx html. As this html index.html file welcome to nginx is coming from this file, so let me change the content so that this is fe pod. Okay, so I have updated the content over here, so the same is visible to you guys. Whatever the things present in the container is going to appear over here. Let's say I'll just say this is fe pod 1111. Okay, I'll just update content one more time. Let's say I'm going to create one more pod. Okay, kubectl run nginx hyphen image. Okay, so I have just created one more pod over here, but I kept the label as a default label, that is run equal to port 2 get pod. And you can see this, the front end pod is having this label type equal to front end, and this pod 2 is having some other label. So that's where a service is never going to send request to this pod. Okay, if you just describe to that service as well, where is the service name? If you even describe to the service, you will see only one endpoint over here, because label is not type equal to front end. If this label is type equal to front end, then definitely uh, within the endpoints I will be able to see the two endpoint details. So let's make this label as type equal to front end. Label pod. Let's remove the run label and let's add the required label, that is nothing but type equal to front end. Okay, so I have just updated the label over here. If you want to see the details of updated label, now both this pod are having type equal to front end. So that's where if I describe it now, you will see two endpoints over here. One belongs to the first pod, second belongs to the second pod. Okay, and let's change the index.html of the pod 2 as well, because I want to show you that is really the requests are getting in the round robin fashion to the pods or not. Okay, so just to do that, kubectl execute -it. Let's log into this pod, and once we user share, what was the content for this? I'll say this is the front end pod. Okay, so I have updated. URL will remain the same. Okay, because this is the service URL. Okay, and service is going to send request to the first pod and second pod. So if I say this, so now you can see request is going to the second pod. If I refresh this page, so it is a kind of sticky bit now. Means this browser is stick to this pod for some period of time, and once we do the hard refresh, then after some time request will go to the first pod as well. So let's do it multiple times just to see the same thing. It's kind of a sticky, or just wait for a moment, or let me do it in the incognito window. So you can see with the same URL I am redirected to this. Now it's sticky over here, so it will happen, but in real time it will be not that much sticky. Okay, the way it is working over here. So I just wanted to explain you with the same URL. If I do the curl to this URL, you will see this is the second pod, and if I do curl to the same URL, you will see this is the pod 1. Okay, so same output, whatever output you can see over the browser, you can able to see the same output with the help of curl on our terminal as well. So I hope now you are able to understand, like or whatever the request coming to this URL, all are getting redirected to the pod, but in the round robin fashion. Understood this much topic? So basically, out of this, for NodePort, it's always a service which is required to expose our pod outside. Like the way we have done, like we have exposed this pod over the browser. In the same way, I meant to say, if you want to connect to this pod from the outside world, like browser, or if you want to give access to someone else about this pod, so that is how a node port is going to work. Just a moment. Audible now? Oh, okay. So I was talking about this node port, just exposing a port over the node, so that people will be able to access this from the browser. Okay, that is the one main thing over here. Let's say this is the pod which are front end, and now I have one more pod over here. Let me drag it down over here. So let's say this is my type as backend. Okay, so this pod is having some Java applications or backend application installed within that. So I don't want to expose this pod outside, like I don't want this pod to be accessed by people, or let's say if you can consider there is some database related to the customer or some banking database is present within this pod. I don't want everyone to see all those database things which are there within this backend pod, but I want this front end pod should be able to access to this backend pod. Okay, that should be there because these pods belong to a same cluster. So I don't think there will be an issue with this connection, like this pod having access to this backend pod. But a direct connection should not be there because there should always be some load balancer in between. Otherwise, direct connection can connect to only a single pod. But what if there are three database pods? So direct connection में फिर किसको request भेजना है, this pod will have to decide. I don't want to provide that much facility to this pod, so that's where what I'm going to define over here. I'll just say, let me redraw this diagram a little bit. So this is the one pod, let's say this is the one more pod, and in that case I'm just going to have one backend service over here. So this backend service will and I'll just hard code the URL of this backend service within this pod. So always if any request will go to this backend service, not from the outside world, okay, only within the pod, within the cluster. Okay, so that request will get redirect to either this or either this. So load balancer funda will still remain same, everything will still remain same. Only thing, this service will not expose pod outside the cluster. This service is mainly within the cluster, and that's why we call that service as a cluster IP. Okay, this cluster itself suggests the name within the cluster IP is a cluster. Okay, that cluster itself will suggest that you can expose the pod only within the cluster, not outside it. So that's where we have to make use of this service. Okay, so if you want to expose outside, use the NodePort service. If you want to expose inside the cluster only, use this cluster IP service. Okay, so let's see in practically how it works. Okay, so as of now we have this NodePort service, and this is the default one. You can ignore default one. So let's uh, have the name as my cluster IP service. Let's say I'll provide type equal to backend, and over here as a case sensitive, so C must be in caps, IP must be in caps. Okay, and as we are not exposing any of the port over our node, so as this thing is required only in case of the node port, so that's where we have provided this. But as we are learning this cluster IP, so you can ignore that. Okay, so I'll just create one more pod with type equal to backend as a selector, and this cluster IP service, okay, my cluster IP SVC is going to send request to that pod. Okay, so that is the thing that we are going to look right now. Let's save it. And one more thing I haven't mentioned till now, if you make use of the type equal to cluster IP, it is going to create a type equal to cluster IP service. But if you skip the type part, if you don't write it down, in that case as well, the default service that it is going to create, that is the cluster IP. Okay, if you mention or if you don't mention, it's one and the same thing for the cluster IP service. So you can see now I haven't mentioned anywhere about the cluster IP service, and if I create this, DNS, okay, my cluster IP. So name of the service should be all lowercase. I have by mistake I have provided this C as a caps in the service name, and IP as well also. Okay, so this entire name must be lowercase as explained over here. Let's apply it one more time. Okay, so that's where like where to provide the caps, where to provide the small, it's very important to understand over here. We have this my cluster IP service. If I describe it, you can see type equal to cluster IP over here. If I describe to this service, there are 0 endpoints over here because there is no pod with label type equal to backend. So let's create a pod. Kubectl run pod 3, and let's provide label as type equal to backend. And if you describe it now, you will have one endpoint right now because the labels are matching. Okay, now let's say if you want to see really see that this service is going to send request to the backend or not. Okay, and is it going to do the load balancing or not? So for that matter, what I'm going to do, I'm going to create one more pod with the same label but different pod name over here, because pod name must be unique. Okay, so one more pod with the same, so there will be two backend C. Okay, this time why it is not type equal to backend. Let me kubectl get pod. So type equal to backend, type equal to backend. We have pod 3, pod okay. So let's describe this service one more time. So now you can see there are two endpoints, as there are two pods belongs to that. Okay, so these are the front end pod. Okay, and these are the back end pod. Let's log into any of the front end pod. Let's say this is the front end pod. And if you do ns lookup to this, so ns lookup is all about resolving to the IP address. So if you just do ns lookup to this, it should resolve to the IP address. So internally the request will go to any of the pod. So ns lookup, I don't think this command should be there within this. Ns lookup command not found, so I have to install this ns lookup command first within this to check this output. I think I have provided a command to install ns lookup in the docker section. Let's for time being I'm trying to install the ns lookup within this pod. Okay, so that I can do the okay. So now you can see this my cluster IP service is have this IP address. Okay, so 10 to 45 24. Okay, so where you can see this IP address, kubectl get SVC. If you do, so this ending with 169 is nothing but this IP address over here. Okay, and this internally will send request to the two pods because in the endpoint section I have showed you there are two endpoints or two IP address available within that. So it's all about the labels. Definitely if you play with label properly, definitely you will not get any issue in redirecting a request from service to the pod. Okay, so this cluster IP service is internal only. It's not something people can go ahead and access from the outside. Okay, only the NodePort service will allow you to allow us or give us facility to access the pod from the browser. Then next one is all about the load balancer service. Why do we actually need a load balancer? Okay, let me explain you one more thing in the NodePort service. Okay, maybe one thing I skip over here. In case of the NodePort service, we make use of this IP address. Okay, let's say curl colon. Okay, I got this output. I can make use of this IP address as well. It is not something कि pod कौन से IP मतलब pod कौन से node पे गया है. It is going to work with both the pod. Maybe let me explain with the diagrammatically only. Things will be better clear. Let's say this is the worker node 1, worker node 2, and this IP address, let's say 1.1.1, over here 2.2.2. Okay, let's say in case of the node port service, the port that is exposed is, let's say, 3008. okay, and the pod got created at this. Even though at the service level it doesn't matter, okay, because we are going to access to this pod via service, that is the NodePort service over here. Okay, so any request coming to this service will get redirected to this pod. Okay, so if you want to access to this pod, so you can make use of this worker node port. So either you can make use of one sorry 8, or you can make use of with the both IP address or both worker node. It is going to work. It's not something ki pod first worker node पे है तो only first IP ही चलेगा, second नहीं चलेगा. It's not something, because it's kind of a load balancing. That's where let's say ये पूरा का पूरा वर्कर नोड चला भी जाता है, still pod will get automatically created at this location because of, let's say, a replica set. Okay, and you will be able to access this pod with another IP address 2.2.2.2. Okay, so if pod is on any of the worker node, still it will be able to access from all the worker nodes IP address. Okay, so there will be two URLs for the same pod to access. So customer ko I don't think this URL to share is a good idea. So that's where what I'm going to do, uh, I'll just okay okay let's say this is a pod over here. So with the help of load balancer service, I'm going to create a load balancer internally. Okay, so this is a load balancer service. This service, load balancer service, is going to send a request automatically. Okay, so this will be only a single URL, not two URL. Okay, this service will automatically send request to this or this. Okay, in case of the NodePort service, there were two URLs, which is not good idea to provide, because एक URL let's say ये पूरा का पूरा चले जाता है, तो out of that two URL, one URL will stop working, and which is not a good thing as a end user, that URL something is not reachable. So that's why I will be having a normal load balancer URL, and that load balancer URL will be a single URL which is going to redirect request to this pod over the worker node. Okay, and internally let's say ये down भी हो जाता है, so still our URL will remain the same. That URL will now redirect all requests to the second worker node. Let's see in practically how these things will work. Kubectl via svc. Only over here the type name will change, my load balancer service, and I have to provide type over here, load balancer. Rest of the things will remain same. And let's change the selector as well. Front end, did not. Okay, there is some issue, I guess so. Okay, type equal to load balancer. These are the ports, selector, all good. Let's apply it now. So this got created, and a load balancer is also created over here, and this load balancer external IP address is pending. So definitely we will get this IP address, and we will be able to access to our pods with this IP address. Now we will not make use of the worker node IP address, we will make use of the IP address of the load balancer. Okay, and this will be the node port internally. Okay, the way we were having this 300, the thing is, okay, let me explain this as well. Let's say load balancer service internally, we make use of the node port service. Okay, in case of the node port, there was a port which was open. We have opened last time 30008. But let's say if you don't define a node port over here, that what node port you want to use, then randomly any of the port between the mentioned range will get picked up. So this time, as I haven't mentioned any of the port number between the range 30,000 to 32767, so automatically one of the free port will get picked up and assigned as a node port. Okay, it's still into the pending condition. Maybe we can just check at the load balancer level if anything is looking. There is one note over here: load balancer and volume should only be managed through kubectl. Changes made in the control panel will be reverted. Okay, and this is the load balancer that we just got created. Just click on it and we will get to see some extra details. The thing is, this load balancer is going to get created within this DigitalOcean. Okay, and within this, okay, so once we access to this load balancer, uh, request will automatically get redirected to this these two servers, and these two are nothing but our worker node. Now I just wanted to look where it is under the creating condition. You can say this is under the creating. It's not 100% created it. Okay, so we just have to wait for it to get it created 100%, and once it got created 100%, then we will get some IP address available over here. Same IP address you will be able to see in the load balancer section as well in the DigitalOcean. And once you are good with that, just hit it over the browser and you will be able to connect to our pod. So that's where a NodePort service is not good if you have more than two or more than two worker nodes. So okay, someone tried to join. If there is only a single worker node, then we are good with NodePort service. But if there are more than one worker node, so there will be multiple URLs. Okay, so we want to avoid those multiple URLs. So that's where we will be having the load balancer service, which will have only a single URL, and it's very easy to provide it to the customer. So that is the main difference between a load balancer service, NodePort service, ClusterIP service. Okay, so I hope you are able to make some clarification over here, that when to use which one and how to use it, all those things. So this is still getting creating. Meanwhile, we can discuss doubts if you are having. So now this load balancer got created successfully, and if you are able to see the get service, it is still in the pending. We should get the IP address of the load balancer. Let's see one more time. Refresh the page. In the backend as well, let me see it one more time. External IP is still pending. Okay, and you can see this is the IP address that we got for the load balancer. Let's do curl to this load balancer IP address colon this port. Okay, it got stuck over here. Let me try to do from the browser once. Okay, from browser as well it is not working, not an issue. I'll try to check, and I'll come back with the solution tomorrow on this. Once we are done with this topic tomorrow, and then only we will start the new topic. Okay, thank you so much for joining. Okay, thank you so much. See you tomorrow. Bye bye. We'll see this topic one more time tomorrow.